Right now, under your feet, the ground is not standing still. Earth's spin is speeding up and slowing down at the same time, breaking speed records scientists cannot fully explain. Its magnetic north pole is sprinting towards Siberia. Deep inside, a metal core the size of Pluto may have stopped turning and reversed direction. Ahead, you will see a lost continent hiding under the Pacific, a giant ocean current that could shut down and freeze half of Europe, and craters in Russia that explode out of the frozen ground like popped balloons. Every fact in this video is real, pulled from current research, and checked twice. If strange science like this pulls you in, tap subscribe so more of it finds you. Take a breath. Hold on to something solid. If you can still trust what solid means, Earth is changing, and the answers keep getting stranger. Every day, somewhere in a quiet room, a machine listens to Earth spin. It is an atomic clock, and it does not lie. For decades, this clock told the same simple story. Earth's spin was slowing down, so slightly that a day only grew longer by about 2 milliseconds every 100 years. Then, in 2020, the story flipped. Earth started spinning faster than it had at any point since these clocks began recording in 1973. Scientists watched in confusion as the planet kept breaking its own speed record year after year. On July 5, 2024, Earth completed one full turn, 1 2/3 milliseconds faster than usual. That sounds tiny, but it was the fastest spin ever measured by machines. Timekeepers had spent decades preparing to add leap seconds to our clocks because Earth was slow. Now they are quietly discussing something that has never happened before, a negative leap second, where a second gets deleted from time itself just to keep up with a planet in a hurry. Picture a figure skater pulling her arms in during a spin. She speeds up instantly, without adding any new energy, just by changing her shape. Earth does something similar. Anything that moves mass closer to its spinning axis, like melting ice sliding off mountains into oceans near the equator, can change how fast the whole planet turns. Scientists have ruled out some causes and are still chasing others, including shifts deep in the planet's molten core, thousands of miles below your feet. Nobody expected this. Nobody predicted it. And nobody currently has a complete answer for why our planet decided, 4 years ago, to start moving through space just a little bit differently than it had for the whole of human history. What changed inside Earth to cause this shift? And why did it happen right now, in our lifetime, instead of 1,000 years ago or 1,000 years from now? Timekeepers have a specific tool for these tiny corrections. Since 1972, the world has added leap seconds, 27 separate times, always adding a second rather than removing one, because Earth had always been the slow one in the relationship. A negative leap second would be the first subtraction in the history of modern timekeeping, and computer engineers are already worried, since much of the world's software has only ever been tested for adding time, never for deleting a second that technically never happened. Google, Meta, and other major technology companies have already begun researching how to handle this glitch quietly, spreading the missing second across many hours instead of applying it all at once, just in case the planet keeps speeding up. Some researchers think the answer might not be hiding in the oceans or the ice at all. It might be sitting nearly 2,000 miles beneath your feet, in a ball of solid iron the size of a small planet, moving in ways almost no one predicted. Beneath your feet, past miles of rock, past a boiling ocean of liquid metal, sits a second planet inside our planet. It is Earth's inner core, a solid ball of iron and nickel almost as wide as the moon. No drill has ever touched it. No camera has ever seen it. Everything scientists know about it comes from listening, the same way a doctor uses an ultrasound to see inside a body without ever cutting it open. Instead of sound waves from a machine, scientists use earthquakes. When a massive quake strikes, it sends vibrations rippling straight through the planet, passing through the inner core like a flashlight beam through fog. By comparing how those vibrations arrive at listening stations around the world, and by comparing quakes that struck the exact same spot years apart, researchers can measure whether the core has turned in between. For 20 years, that measurement produced a strange back and forth. Some studies found the core spinning faster than the rest of the planet. Others found it barely moving at all. In 2024, a team at the University of Southern California settled part of the argument. They studied earthquakes from a remote island chain in the South Atlantic, comparing signals recorded as far back as 1991. Their conclusion, published in the journal Nature, was that the inner core had been spinning slightly faster than the surface for decades, then slowed around 2009 and has now been drifting backward compared to the mantle around it. Backward does not mean the whole planet stopped or reversed. It means this hidden inner sphere is now turning a tiny bit slower than the rock and ocean floor above it, drifting the other direction relative to us, like a runner on an inside track falling slightly behind. Researchers believe this happens in a cycle lasting around 70 years, pulled back and forth by the churning liquid metal that surrounds the core and by gravity from the uneven rock of the mantle above it. A newer study from the same team, published in early 2025, found something even stranger. The surface of the inner core itself might be changing shape as well as direction, in movements that resemble slow landslides happening more than 3,000 miles down. Scientists still argue over what causes any of this, and some think the whole idea of the core reversing needs more proof. The South Sandwich Islands, the exact spot researchers focused on for their most convincing evidence, sit almost perfectly opposite Alaska on the globe, a remote volcanic chain few people have ever heard of, chosen specifically because repeating earthquakes there let scientists compare identical seismic paths through the core across more than 3 decades. That kind of natural repeat experiment almost never exists anywhere else on the planet, which is part of why this particular patch of ocean became so important to solving a mystery buried thousands of miles beneath it. One thing is agreed on by nearly everyone studying it. Directly beneath every step you take, there is a hidden world turning at its own pace, tied to Earth's spin, its magnetic field, and possibly to those shrinking milliseconds ticking away on the atomic clocks above. Grab a compass, right now, in your mind, and picture the needle swinging until it settles, pointing toward magnetic north. That needle is not pointing at a fixed spot. It has been sprinting across the top of the world for the last 30 years, and scientists are struggling to keep up with it. Magnetic north used to sit calmly in northern Canada for most of the 20th century, drifting a few miles a year, slow enough that maps barely needed updating. Then, in the 1990s, it began accelerating. By the 2000s, it was crossing the Arctic Ocean towards Siberia at speeds of over 30 miles a year, faster than it had moved in recorded history. Navigation systems, military maps, and even smartphone compasses rely on models that must now be updated far more often just to stay accurate. This magnetic field comes from something similar to the mystery locked inside the last chapter. Deep in Earth's outer core, an ocean of liquid iron churns and swirls, acting like a giant, sloppy electric generator. That churning motion is called the geodynamo, and it is what wraps our entire planet in an invisible magnetic shield, the same shield that protects us from dangerous particles blasted out by the sun. Airports have felt this shift directly. Every runway on Earth is labeled with numbers based on the compass direction it faces, rounded to the nearest 10 degrees. As magnetic north keeps sliding, some runway numbers have become wrong enough that airports have had to repaint them, changing a runway labeled 27 to a runway labeled 28, just to match reality. Pilots who trust old charts could genuinely be pointed in the wrong direction. Nobody fully knows why the acceleration happened, though most researchers link it to a shifting patch of intense magnetic activity beneath Siberia, tied to the same churning currents that stir the outer core. Some models suggest the sprint could slow down again in the coming years. Others suggest we simply do not have enough history of precise measurements to know what counts as normal for a magnetic pole that has wandered across the globe many times before, over millions of years. Older evidence for the pole's wandering goes back centuries. Sailors navigating by compass during the age of exploration recorded magnetic readings that, when compared to modern data, show the pole crawling in loops and slow spirals across the Arctic for hundreds of years before its recent sprint began. Historical shipwreck logs and old naval charts have become an unlikely resource for modern geophysicists, offering a centuries-deep record of exactly how much the invisible shield above us has always been in motion, just usually too slowly for anyone alive at the time to notice. If the pole itself can move this fast without warning, the bigger question is, what else about Earth's magnetic shield might already be shifting in ways we have not fully mapped yet? Halfway around the world, above South America, something is happening to that same shield that has satellite engineers far more worried than a moving compass needle ever could. Above South America and the South Atlantic Ocean, there is a hole in Earth's armor. Scientists call it the South Atlantic Anomaly, a massive region where the magnetic field protecting our planet is dramatically weaker than everywhere else. It stretches across an area bigger than the continental United States, and satellites that fly through it have to prepare for trouble. Earth's magnetic field normally deflects most of the charged particles that blast off the sun, acting like a raincoat in a storm. Inside the anomaly, that raincoat has a thin patch. Radiation from space dips much closer to the surface here than anywhere else on the planet. Satellites passing through often get hit by energetic particles that can scramble their electronics. So many spacecraft operators, including teams running the International Space Station, power down sensitive instruments every single time they cross it. For years, scientists assumed this weak spot was simply drifting slowly westward, shrinking or growing at a steady pace. Newer satellite data, gathered by the European Space Agency's Swarm mission and NASA's long-running monitoring programs, revealed something nobody expected. Since around 2020, the anomaly has begun splitting into two separate lobes, each with its own center of weakness, drifting apart from each other over the South Atlantic and Africa. NASA geophysicists studying the split think it connects to a massive, mysterious structure sitting nearly 2,000 miles beneath Africa, a giant blob of unusually dense rock at the boundary between Earth's core and mantle. That deep structure may be distorting the magnetic field being generated below it, similar to how a rock under a rug creates a bump on the surface far above. Here is the part that keeps researchers up at night. Similar magnetic weak spots have appeared in Earth's ancient history, right before the planet's entire magnetic field flipped poles completely, a process called a geomagnetic reversal that has happened hundreds of times over Earth's history, most recently around 780,000 years ago. Scientists studying the anomaly are careful to say there is currently no solid evidence a full reversal is starting now. They also admit that a splitting, growing, drifting weak spot is exactly the kind of pattern you would expect to see in the earlier stages of one. The anomaly is not a modern invention either. Researchers studying ancient volcanic rock, which locks in a faint record of Earth's magnetic field the moment it cools and hardens, found evidence of a strikingly similar weak zone over the same general region roughly 11 million years ago, long before satellites or spacecraft existed to be threatened by it. That discovery reassures some scientists, since a weak spot that has appeared and faded away before suggests this current version could behave the same way, rather than being the first stage of something entirely new. Whatever is happening above South America is being driven by something even stranger far below it, at a boundary layer where Earth's rocky mantle finally gives way to its liquid metal heart. Rock does not usually flow. Pour water and it spreads instantly. Pour rock and nothing happens, at least not on any time scale a human could witness with their own eyes. And yet, the entire surface of our planet rides on rock that behaves exactly like a slow-moving liquid given enough time. Beneath Earth's thin, brittle crust sits the mantle, a layer of hot rock nearly 1,800 miles thick. It is solid, the same way a stick of very hard toffee is solid, but under the crushing pressure and heat found deep inside the planet, that solid rock can bend, stretch, and creep, moving at roughly the speed your fingernails grow. Over millions of years, that impossibly slow crawl is powerful enough to drag entire continents across the globe, open new oceans, and build mountain ranges from nothing. Scientists map this hidden flow using the same earthquake vibrations used to study the inner core, except this time they are watching how seismic waves slow down or speed up as they pass through different pockets of mantle rock. Cooler, denser rock lets waves travel faster. Hotter, more flexible rock slows them down. Piecing together thousands of these measurements builds a three-dimensional picture of currents inside the Earth. Currents too slow for any human to feel, yet strong enough to reshape the entire planet over deep time. Two colossal structures stand out in these mantle maps, each roughly the size of a continent, each nearly twice as tall as Mount Everest, sitting right where the mantle meets the core almost 1,800 miles down. One sits beneath Africa, the other sits beneath the Pacific Ocean. Scientists still argue over what these giant blobs actually are, whether they are ancient, unusually dense rock left over from Earth's early formation, or something stranger tied to an ancient collision billions of years ago. Their presence appears to be linked to the same deep magnetic weirdness driving the anomaly above South America. Scientists have given both deep blobs an intentionally plain name, calling them large, low shear velocity provinces, simply because seismic waves shear or bend unusually slowly as they pass through this dense rock compared to the material surrounding it. Some researchers suspect these structures have sat almost undisturbed since Earth's earliest history, acting like anchors that the entire churning mantle flows and swirls around. Similar to how a boulder sitting in a fast-moving river forces the current to bend and eddy around it for a long stretch downstream. This slow, hidden churn beneath the crust connects almost everything so far: the drifting magnetic pole, the weakening shield above South America, and the reversing core spinning below it all. Yet even this deep, grinding motion is not the strangest way our planet has been caught moving off balance. Above the mantle, above the crust, the entire planet itself has started to wobble. Spin atop on a table and watch closely. It never spins in one perfectly straight line. It wobbles, tracing a small, wandering circle as it turns. Earth does something almost identical, and scientists gave this wobble a name back in the 1800s, the Chandler wobble, after the American astronomer who first measured it. As Earth spins, its axis, the invisible line running from the North Pole to the South Pole, does not stay perfectly still. It traces a loose, drifting loop, moving the actual location of the poles by several yards over a cycle lasting about 14 months. This has been happening for as long as Earth has existed, caused partly by the planet's slightly uneven shape and by shifting pressure on the ocean floor. For over a century, this wobble followed a fairly predictable pattern, drifting steadily in one general direction across the Arctic. Then, around the year 2000, something changed. The drift suddenly shifted direction, swinging the other way, and it kept accelerating faster than anyone expected. Researchers spent years trying to explain it, testing theories involving melting glaciers, shifting ocean currents, and changes in the mantle far below. A major clue arrived when scientists combined decades of satellite gravity data with careful modeling. The surprise culprit turned out to be groundwater, the water humans pump out of the ground for drinking, farming, and industry across the globe. Removing that much water from underground reservoirs and spreading it across the ocean through rivers and evaporation shifts mass around the entire planet, similar to adding a small weight to one side of a slowly spinning globe. Enough water has been pumped out of the ground worldwide since 1993, roughly 6 trillion tons, to physically tilt Earth's spin axis by more than a foot. The scale of the shift stunned even the researchers who found it. Before the year 2000, the wobble drifted a steady few inches per year in roughly one direction. After the reversal, it began drifting more than 4 times faster in the opposite direction, a swing large enough that a NASA-led team could match it almost exactly against maps of where groundwater had vanished across India the Middle East, and California, three regions responsible for a huge share of the planet's total groundwater loss during that same stretch of years. This means something almost impossible to picture, that farmers running irrigation wells and cities pumping drinking water have collectively nudged the direction our entire planet leans as it spins through space, an effect large enough for satellites to measure from orbit. The wobble itself is harmless to anyone standing on the surface. What it reveals is not harmless at all. A hidden connection between human water use on the surface and the physical motion of the whole planet, a connection that becomes far more alarming once you look at where all that missing water actually went. Satellites do not need a bucket or a well to find water. They can measure it from more than 300 miles above Earth's surface, using nothing but gravity. Two spacecraft, flying in a tight formation for NASA's Grace mission, chase each other around the planet, and whenever one flies over a heavier patch of Earth, even something as invisible as a hidden reservoir of underground water, gravity tugs it forward by a fraction of a millimeter. Scientists turn that tiny stretch between the two satellites into a detailed map of where water is disappearing. What that map revealed shocked hydrologists across the world. Regions once thought to have deep, reliable groundwater supplies were draining fast, in some cases faster than rainfall or rivers could ever refill them. Northern India lost enough groundwater in a single decade to fill a lake the size of Lake Erie, California's Central Valley, Saudi Arabia, and the farmland belts of the American Great Plains all showed the same warning signs. Invisible reservoirs, shrinking year after year, drained through millions of wells, drilled deeper and deeper to keep up with farming and city growth. This groundwater took thousands, sometimes tens of thousands of years, to accumulate underground, filtered slowly through layers of rock and soil. Pumping it out in a matter of decades is like draining a swimming pool that took a century to fill, using a hose running 24 hours a day. Once it is gone, in many places, it does not come back on any timescale that matters to the people living there now. The water does not vanish once it is pumped up. Much of it gets used for crops, evaporates into the atmosphere, and eventually rains down somewhere else, often falling into the ocean. This is part of why global sea levels have risen faster than melting ice alone can explain, an invisible contribution from water that used to sit safely underground and now sits in the ocean instead. Scientists estimate groundwater depletion has added roughly the thickness of a fingernail to global sea level since the 1990s, small on its own, but part of a growing total that keeps climbing. Farming accounts for the largest single share of this disappearing water, since roughly 70% of all groundwater pumped worldwide goes toward irrigating crops, particularly in dry regions where rainfall alone cannot support the amount of food being grown there. Some governments have started requiring farmers to report exactly how much they pump, while others have begun capping new well permits entirely, though enforcement remains difficult across regions where millions of small farms each draw a modest amount, individually easy to overlook, collectively responsible for one of the largest human-driven shifts in Earth's water ever measured. The ground itself is not indifferent to losing that water. Where an underground reservoir once held rock and soil apart like a cushion, the layers above can slowly collapse inward once the water is gone, and that collapse does not stay hidden underground for long. It reaches all the way up to the surface, into the streets, sidewalks, and foundations of some of the largest cities on the planet. Jakarta, Indonesia, is sinking so fast that officials are relocating the entire national capital to a new city built somewhere else. Parts of the city have dropped more than 8 feet in the last 30 years, and roughly 40% of Jakarta now sits below sea level, protected only by seawalls that keep needing to be built higher. It is something happening directly underground, with no ocean waves or coastal erosion involved at all. As millions of residents pump water out of aquifers faster than rain can refill them, the empty spaces those aquifers once held simply cave in, like a mattress losing its stuffing. The land above sinks along with it, slowly, silently, and almost impossible to reverse once it has happened. Jakarta is far from alone. Houston, Texas, has sunk several feet in some neighborhoods due to oil, gas, and groundwater extraction combined. Mexico City, built on the drained bed of an ancient lake, has sunk more than 30 feet over the last century. So much that some subway stations now sit crookedly below street level and building foundations crack as the ground beneath them settles unevenly. Venice, Italy, has famously struggled with flooding for decades, worsened by both rising seas and slow ground subsidence beneath its ancient canals. Scientists using satellite radar have found that this sinking problem is far larger and more widespread than most people realize. A 2024 global study tracking land movement in the world's largest coastal cities found measurable sinking in every single one studied, with some areas dropping faster than sea levels are rising, meaning the water is effectively rushing up to meet these cities from two directions at once, rising oceans above and sinking ground below. Not every sinking city has given up. Tokyo managed to nearly halt its own subsidence decades ago by strictly regulating groundwater extraction starting in the 1960s, proving the trend can be slowed once a government commits to the trade-off of finding water elsewhere. Jakarta's leaders studied that exact example while planning their new capital, though critics note that stopping the sinking does nothing to undo the feat of elevation the city has already lost. Elevation that will not simply rise back up again once the pumping finally stops. The fix sounds simple: stop pumping so much groundwater and let the aquifers refill. In practice, cities of millions of people cannot simply switch off their water supply, especially in regions already struggling with drought. Some cities have tried injecting treated wastewater back underground to slow the sinking, with mixed results. For now, the ground beneath some of the most populated places on Earth continues settling downward year after year, while the water pumped out of it flows toward an ocean that is already rising to meet it, driven partly by a current thousands of miles away that is now slowing down in ways that could reshape weather across entire continents. Off the coast of Florida, scientific instruments have been quietly tracking one of the most important machines on the planet since 2004, and that machine is not built by humans. It is a current of water running through the entire Atlantic Ocean called the Atlantic Meridional Overturning Circulation. Think of it as a conveyor belt the size of an ocean, carrying warm water north from the tropics and cold water back south along the ocean floor. This current does more than move water around. It carries an enormous amount of heat, roughly equal to the output of 1 million nuclear power plants, from the equator up toward northern Europe. Without it, countries like the United Kingdom and Norway would be far colder than they currently are, despite sitting at the same latitude as parts of freezing Canada. This overturning circulation is the main reason northern Europe enjoys mild winters instead of brutal, Arctic ones. The engine driving this current relies on salt water becoming cold and dense enough near Greenland to sink toward the ocean floor, pulling more warm water up from the tropics behind it. As Greenland's ice sheet melts faster each year, it dumps enormous amounts of fresh water into the North Atlantic. Fresh water is lighter than salty water, so it resists sinking, and that resistance is throwing sand into the gears of the entire conveyor belt. Two major studies released in 2025 and 2026, using real measurements from ocean monitoring stations rather than only computer models, confirmed this overturning circulation has been weakening at multiple points across the Atlantic over the past 2 decades. Researchers from the University of Copenhagen went further, estimating in an earlier widely discussed study that under current warming trends, the current could collapse entirely sometime between 2025 and 2095, with growing scientific debate over whether the earliest stages of that slowdown are already locked in. Not every scientist agrees on how close a full collapse actually is, and some caution that predicting an exact tipping point remains extremely difficult given how complex ocean systems are. What almost everyone studying this current agrees on is its direction, steadily weakening, and the consequences of a full shutdown would ripple far beyond one ocean, reaching African rainfall, American droughts, and rising seas along the entire eastern coast of the United States. Ocean monitoring for this current relies on a network of moored instruments anchored to the seafloor along the entire width of the Atlantic, stretching from the coast of Florida to the coast of Africa, constantly recording temperature, salinity, and current speed at different depths. Researchers from the University of Miami, who published one of the most alarming recent studies, pulled their data from 4 separate mooring lines, spanning the western half of that network, finding weakening at every single one, a level of consistency that made the result far harder to dismiss as noise in any one location. If a current this massive can begin failing without most of the world noticing, it raises an unsettling question about what else might be quietly breaking down in a part of the planet almost nobody watches closely, the frozen ground of the far north. If the Atlantic current fully shuts down, the clearest warning sign will not come from a graph or a satellite. It will come from winter itself, changing shape across an entire continent. Modeling from climate scientists suggests parts of northern Europe could see winter temperatures drop by anywhere from 9 to 27 degrees Fahrenheit compared to today, a shift severe enough to push growing seasons shorter, strain power grids built for milder winters, and disrupt farming across a region that currently feeds hundreds of millions of people. The changes would not stop at Europe's coastline. Scientists tracking rainfall patterns expect this weakened current to drag the entire tropical rain belt southward, the same belt of rainfall that farmers across Africa, Asia, and South America depend on for their crops. Shifting that belt even slightly could turn currently fertile farmland into drought zones, while other regions see rainfall arrive in the wrong season entirely, too much water at the wrong time, or none at all when crops need it most. There is a strange twist buried inside this cooling scenario. Even as parts of Europe potentially freeze, the rest of the planet keeps warming from greenhouse gases. Researchers studying a full shutdown of this current found it could actually accelerate warming in the tropics, since the current currently exports a huge amount of heat away from the equator toward the poles. Remove that export system, and heat piles up exactly where it is already dangerous, in regions already struggling with extreme temperatures. Sea levels along the eastern coast of the United States would rise faster too, because this Atlantic current currently pulls water away from the American coastline as part of its circulation pattern. Slow that current down, and water that would have been carried elsewhere instead piles up along cities like New York, Boston, and Miami, adding inches of sea level rise on top of what is already happening from melting ice worldwide. Researchers remain divided over exactly when, or even whether, a full collapse will happen this century, and some studies argue the statistical methods used to predict a tipping point are not yet reliable enough to trust completely. What almost every oceanographer studying this system shares is a growing sense of unease. This current has already surprised scientists once by weakening faster than older models predicted, and a system capable of surprising researchers about its speed could just as easily surprise them about its timing too. Peter Deitlevson, the researcher behind one of the most widely discussed collapse timelines, built his prediction using more than a century of ocean temperature records rather than only running future climate simulations, applying statistical methods borrowed from fields like structural engineering that watch for the telltale wobbling a system shows right before it tips into a completely different stable state. His own estimate, a collapse arriving sometime between 2025 and 2095 with 95% confidence in his method, remains one of the most cited and most contested numbers in modern climate science. Thousands of miles away, in a landscape most people will never visit, another slow-moving disaster has already stopped hiding underground and started breaking through the surface completely. In 2014, herders on Russia's remote Yamal Peninsula found something that should not exist: A massive crater had appeared in the frozen tundra, seemingly overnight, roughly 230 feet across and over 150 feet deep, its rims scattered with chunks of frozen soil blasted outward with enough force to suggest a genuine explosion. Within a decade, researchers had found more than 20 similar craters scattered across the same remote region and nowhere else on Earth. For years, scientists debated fiercely over what caused them. Some suspected buried gas reserves. Others pointed to melting permafrost, releasing trapped methane. None of the early explanations fully matched the region's unusual underground geology. In 2024, a team of researchers led by chemical engineer Anna Morgado at the University of Cambridge published a detailed model that finally pieced the puzzle together, describing a process almost nobody had considered before. Beneath the frozen ground of Yamal sits a bizarre sandwich of layers. Solid permafrost sits on top. Below that, hidden between 3 feet of salty, unfrozen water called a cryopeg. And below that, a layer of methane hydrate, essentially methane gas frozen solid within ice. As surface temperatures rise, meltwater trickles downward through the permafrost and seeps into the salty cryopeg layer. That salty water pulls in the fresh water through a natural process called osmosis, the same force that moves water across a cell membrane. Except here, it happens on a scale that can swell an underground pocket like a slowly inflating water balloon. Pressure builds for years, sometimes decades, completely invisible from the surface. Eventually, the swelling cracks the frozen ground above it, and the sudden pressure release destabilizes the methane hydrate layer below, causing it to decompose explosively into gas. The result is a blast powerful enough to launch frozen Earth hundreds of feet through the air, leaving behind a smoking crater in the middle of an empty, silent landscape. Not every researcher agrees this fully solves the mystery. Scientists who have studied the craters up close for years argue the permafrost in this exact region is too thick and too ice-dense for meltwater to realistically reach these deep, salty layers at all, meaning the true trigger may still involve gas, seeping upward from ancient reserves formed over 65 million years ago. Whichever explanation eventually wins, every single explosion releases fresh methane, a greenhouse gas far more powerful than carbon dioxide, directly into the atmosphere, adding a small but real feedback loop to a planet that is already warming. Local herders on the Yamal Peninsula had actually reported hearing loud underground rumbling and seeing ground swelling for days before at least one crater formed, giving scientists rare, real-time human testimony to compare against their models of how pressure builds before an explosion. Reindeer herds in the region have learned to avoid these swelling mounds entirely, an instinct researchers now take seriously enough that some expeditions specifically ask local herders to point out suspicious ground before setting up monitoring equipment nearby. The permafrost holding these craters together is not only cracking apart under pressure, it has also begun waking something up that has not moved in tens of thousands of years. Permafrost works like a natural freezer that has been running, uninterrupted, for tens of thousands of years, and like any freezer, it preserves whatever gets locked inside it. In 2014, French scientists thawed out a sample of Siberian permafrost that had remained frozen for roughly 30,000 years and found something inside it that immediately started moving again. It was a virus, later named Pithovirus sibericum, and researchers confirmed it was still infectious after 30 millennia trapped in ice, able to infect a single-celled organism the moment conditions allowed it to. Researchers have since revived multiple ancient viruses, from Siberian permafrost, along with bacteria and even microscopic worms called nematodes that resumed moving and feeding after being frozen for an estimated 46,000 years, roughly the same span of time separating us from the last ice age's coldest point. None of the viruses revived so far are known to be dangerous to humans, since researchers deliberately study ones that only infect amoebas, single-celled organisms far simpler than any human cell. The concern scientists raise is not about that specific virus. It is about what else might be waiting in permafrost across Siberia, Alaska, and northern Canada, an area covering nearly 9 million square miles, most of which has never been carefully sampled for ancient pathogens at all. Permafrost acts almost like a natural time capsule for disease. Historical outbreaks, including deadly ones, have been buried in graves across the Arctic for over a century, sealed beneath ground that stayed reliably frozen the entire time. In 2016, a heatwave in Siberia thawed permafrost deep enough to expose the frozen carcass of a reindeer that had died of anthrax decades earlier. The bacteria reactivated, sickened dozens of people, and killed one child, along with over 2,000 reindeer, in an outbreak scientists directly linked to permafrost thaw, exposing long-buried spores. Researchers studying this risk stress that a full-blown pandemic emerging from ancient ice remains a low-probability event, since most microbes cannot survive being frozen for that long, and the ones that can are rarely equipped to infect modern humans or animals. What worries scientists more is the sheer scale of what remains unexamined. An area of frozen ground roughly the size of the entire United States and Canada combined, thawing faster every single year, with no complete inventory of what has been sealed inside it. Researchers reviving these ancient organisms follow strict safety protocols, working only with viruses known to infect amoebas, rather than anything capable of infecting animals or humans, specifically to study how a virus survives dormant for so long without collecting anything genuinely dangerous. Jean-Michel Claverie, one of the French researchers behind the original 2014 discovery, has argued publicly that permafrost across the Arctic should be treated as a legitimate biological archive, worth cataloguing carefully before it thaws on its own, rather than being studied only after ancient material has already reached the surface uncontrolled. Whatever else is locked in that ice, one substance, trapped alongside it, is completely certain, and it does not need to infect anyone to cause damage, because it is already leaking straight into the atmosphere. Light a match over the surface of certain Arctic lakes, and the water itself can catch fire. It is a real demonstration, one researchers and even curious locals have filmed for years across Siberia and Alaska, where bubbles of ancient methane rise steadily up through lake water and burst at the surface, releasing gas trapped since long before human civilization began. Methane forms constantly at the bottom of these lakes, produced by microbes breaking down organic material, ancient plants, and animals that froze into the permafrost thousands of years ago and are now, for the first time, finally thawing and decomposing. As that permafrost melts along lake edges, it releases carbon that has been locked away since long before the pyramids were built, and microbes convert it into methane gas that seeps upward through the water in a slow, constant stream of bubbles. Scientists studying one heavily monitored lake in Alaska found something particularly alarming: methane escaping through spots called seeps that had been steadily growing larger and more numerous for years, tracked using both underwater sensors and repeated satellite images taken over time. Some of these lakes are expanding themselves, growing wider each year as the thawing permafrost around their edges collapses into the water, which then exposes even more frozen ground to melt, feeding a cycle that keeps accelerating on its own. The scale of carbon locked in Arctic permafrost is difficult to picture using ordinary comparisons. Scientists estimate the total amount of carbon frozen in permafrost worldwide is roughly twice the amount currently floating in Earth's entire atmosphere, an amount that took tens of thousands of years to accumulate, sealed safely away until now. Even a fraction of that carbon escaping as methane, a gas that traps roughly 80 times more heat than carbon dioxide over a 20-year span, could meaningfully accelerate global warming beyond what current climate models already predict. There is an even deeper reservoir scientists watch closely: methane hydrates locked within frozen layers on the Arctic ocean floor itself, sometimes called flammable ice, because of how the frozen gas can be lit and burned directly. These deep marine deposits have remained largely stable so far, but researchers tracking ocean floor temperatures near Siberia have documented warming water reaching depths that were previously assumed to be permanently frozen and undisturbed. Alaska's SEA Lake became one of the most closely studied methane seeps in North America after researchers noticed its bubbling had grown intense enough to keep the lake from freezing solid even during the coldest months of freezing. Winter, an unusual sight across a landscape where every other lake nearby stays locked under ice for much of the year. Scientists installed underwater sensors and repeat aerial surveys there, specifically because a lake that refuses to fully freeze offers a rare, visible signal of how much ancient carbon is escaping upward in real time. Not every scientist agrees on how fast this frozen reservoir could destabilize, and some research suggests a sudden, catastrophic release remains unlikely within the next century. What almost every researcher studying the Arctic agrees on is simpler and more unsettling. That ground once considered permanently frozen no longer deserves that name, and a desert that once sat beneath open sky, thousands of miles south of any ice, offers a strange kind of preview for what a completely different Earth can look like. The Sahara Desert stretches across an area roughly the size of the entire United States, an endless landscape of sand dunes and bare rock so dry that some regions have not seen meaningful rainfall in recorded human history. 6,000 years ago, this exact same land was covered in lakes, rivers, grasslands, and forests, home to hippos, crocodiles, and giraffes, along with human communities who left behind cave paintings depicting swimmers and herds of cattle grazing across green plains that no longer exist. Scientists call this lost era the African humid period, and it did not end because of anything humans did. It ended because of a slow, predictable wobble in Earth's orbit around the Sun. Earth's axis does not point in a perfectly fixed direction through space. It slowly traces a wide circle over about 26,000 years, a motion called precession, similar to the wobble of a slowing spinning top, except one cycle here takes longer than all of recorded human civilization combined. That wobble changes exactly when Earth is closest to the Sun during its yearly orbit, which shifts the strength of seasonal monsoon rains that used to sweep much further north into what is now the Sahara. Roughly 11,000 years ago, that wobble pushed monsoon rains deep into North Africa, transforming the region into a green landscape that lasted for thousands of years. As the wobble continued its slow cycle, the rains retreated southward again, and the Sahara dried out into the desert familiar today. A transformation that researchers studying ancient lake sediments estimate happened over just a few centuries, remarkably fast for a change of that scale. Here is the detail that turns this into more than ancient history. That same orbital wobble never stopped. It is still slowly turning today, exactly as predictable as a clock, and climate scientists studying these long cycles project that within roughly another 10,000 to 15,000 years, the monsoon rains are expected to shift northward again, potentially turning significant parts of the Sahara green once more, entirely independent of anything happening with modern climate change. Evidence for this lost green Sahara does not rely only on climate models either. Archaeologists working in Libya and Chad have uncovered fossilized fish bones, hippo remains, and thousands of ancient rock paintings depicting cattle herding and swimming scenes across what is now some of the driest, most inhospitable desert on the planet, physical proof that people once lived a settled, water-dependent life in a landscape their descendants would eventually be forced to abandon entirely as the rains retreated south. This does not mean anyone alive today will see a green Sahara. It does mean the driest, most lifeless-seeming landscape on the planet is not a permanent feature of Earth at all, but simply the current chapter in a repeating cycle that has turned this exact patch of land from grassland to desert and back again more than once across Earth's deep history, driven entirely by the same subtle tilt and wobble that also controls something far more dramatic, hiding beneath one of America's most famous national parks. Beneath Yellowstone National Park sits one of the most dangerous geological features on the entire planet, a supervolcano capable of an eruption powerful enough to bury much of North America in ash and potentially disrupt Earth's climate for years afterward. It has not erupted on that catastrophic scale in roughly 640,000 years. What it does instead, constantly, is breathe. Scientists have placed satellite positioning stations across Yellowstone that can detect ground movement as small as a fraction of an inch, and what those stations reveal is that the entire caldera floor, an area roughly the size of a small city, rises and falls in a slow, repeating rhythm. Between 2004 and 2010, parts of the caldera floor rose nearly 10 inches, an unusually rapid uplift for a volcanic system this size, before slowing and settling back down again over the following years in a pattern researchers describe as the ground essentially inhaling and exhaling. This breathing motion comes from a massive underground reservoir of partially molten rock sitting just a few miles beneath the surface, connected to an even larger, deeper magma chamber that scientists have mapped using seismic imaging, similar to the earthquake-based techniques used to study the inner core and mantle. As magma and hot fluids shift and pressurize within these chambers, the ground above responds by physically rising, then relaxing again as pressure eases, a cycle that has repeated for as long as scientists have been able to measure it. Yellowstone's frequent earthquakes are part of this same breathing system. The park experiences over 1,000 recorded earthquakes most years, the vast majority too small to feel, caused by shifting fluids and stressed rock deep underground rather than the caldera preparing for imminent eruption. Scientists monitoring the park stress repeatedly that current activity, including the rising and falling ground, sits well within normal historical patterns, and that a catastrophic eruption remains extremely unlikely on any timescale that matters to anyone alive today. Yellowstone's hydrothermal features, its famous geysers, hot springs, and bubbling mud pots, are the most visible surface evidence of this same underground heat, and park scientists track thousands of small earthquake swarms every year, partly to make sure magma movement stays consistent with decades of established background patterns. Old Faithful itself, the park's most famous geyser, has slightly changed its eruption timing over the past century, a small but carefully logged reminder that even the park's most predictable attraction sits directly above a restless, living system. What makes Yellowstone worth watching closely is the rare opportunity it offers, far more than any fear of imminent disaster. It is one of the only places on Earth where scientists can directly observe, in real time, the same kind of deep, slow, powerful forces that shape volcanoes and continents everywhere else on the planet, just usually too slowly or too deeply buried to ever notice. Some of those same deep forces, working over a much longer stretch of time, once quietly hid an entire continent so well that humanity did not officially recognize it existed until several years ago. Somewhere in the South Pacific, tourists ride a car ferry between the two main islands of New Zealand, crossing 3 hours of open water without realizing what lies directly beneath their boat. It is a continent nearly the size of India, and 94% of it sits underwater, hidden beneath the waves for the last 23 million years. Scientists call it Zealandia, and while a geophysicist first proposed the name back in 1995, it took until 2017 for a team of 11 geologists, led by researcher Nick Mortimer, to formally confirm it met every scientific requirement to be classified as Earth's 8th continent. Their study, published in a leading geology journal, measured a continuous slab of crust nearly 5 million square kilometers wide, made of the same granite and sedimentary rock found on every other continent, sitting up to 2 miles higher than the surrounding ocean floor and running far thicker than typical sea floor crust. New Zealand itself, along with New Caledonia and a scattering of small islands, represents just the highest peaks of this enormous sunken landmass, poking above the surface like the tip of an iceberg turned upside down. The rest of Zealandia once stood above sea level too, covered in forests and rivers roughly 85 million years ago, before slowly stretching, thinning, and finally sinking beneath the ocean as it separated from the ancient supercontinent that once connected it to Australia and Antarctica. For centuries, explorers and geologists simply treated the region as a scattered collection of islands, never considering it might be one single, coherent piece of continental crust. Confirming Zealandia required detailed satellite gravity maps of the seafloor, something that only became precise enough for this kind of discovery in the last few decades, essentially giving scientists a way to see the shape of the ocean floor, the same way earlier explorers mapped the shape of dry land. New Zealand's own geology makes far more sense once viewed as the exposed tip of a full continent rather than an isolated island chain. Its unusually tall mountains for such a small landmass, its frequent, powerful earthquakes, and its string of active volcanoes all fit naturally into the picture of a continent still being actively squeezed and lifted along the boundary between two major tectonic plates, the same restless boundary responsible for pushing Zealandia's highest peaks just far enough above the waves for humans to eventually notice them at all. Zealandia is not a dead, forgotten slab of rock either. It straddles the boundary between two of Earth's major tectonic plates, meaning New Zealand's frequent earthquakes and active volcanoes are direct evidence that this sunken continent is still being pushed, stretched, and reshaped today, just like every other piece of Earth's crust. If an entire continent can hide from official science for centuries simply because it sits underwater, it raises an obvious question about what else remains hidden in the deep ocean, in places even less explored than the shallow seas surrounding New Zealand. In 1977, scientists exploring the ocean floor near the Galapagos Islands, using a deep-sea submersible, made a discovery that broke a rule biologists had trusted for as long as biology existed as a science. They found thriving communities of life clustered around towering underwater chimneys, called hydrothermal vents, giant tube worms taller than a person, ghostly white crabs, and clams the size of dinner plates, all living in complete darkness over a mile beneath the surface, in water hot enough to melt lead near the vent openings. Every ecosystem scientists had ever studied before this depended, in some way, on sunlight. Plants capture sunlight and turn it into energy, and every animal on the food chain ultimately depends on that process. These deep-sea communities had no sunlight at all, and yet they were bursting with life, some of the densest concentrations of biomass found anywhere on the ocean floor. Scientists needed an entirely new explanation for how life this abundant could exist in total darkness. The answer turned out to be chemosynthesis, a process where specialized bacteria convert chemicals spewing out of the vents, particularly hydrogen sulfide, the same compound responsible for the smell of rotten eggs, directly into usable energy without needing sunlight at any step. These bacteria form the base of an entire food web built from chemistry instead of light, supporting tube worms that have no mouths or digestive systems at all, instead hosting these energy-producing bacteria directly inside their own bodies in a permanent, mutual partnership. This discovery reshaped how scientists think about where life can exist, both on Earth and potentially elsewhere. If life can thrive using pure chemistry instead of sunlight here on our own planet, it opens a genuine scientific possibility for similar life existing beneath the icy, sunless oceans, hidden under the surface of moons, like Europa and Enceladus, both orbiting distant planets in our solar system, places where astrobiologists now consider hydrothermal vents a realistic environment worth searching for signs of life. Thousands of these vent systems have since been discovered scattered across Earth's ocean floors, many of them still completely unexplored, tucked along volcanic ridges where tectonic plates slowly pull apart from each other. Each new vent system tends to reveal species never seen anywhere else, adapted specifically to that one small patch of scalding, mineral-rich water. Researchers estimate that the vast majority of Earth's deep ocean floor, an area covering well over half the entire planet's surface, remains almost completely unmapped and unexplored, meaning discoveries this strange are still waiting, quietly in the dark. Some of the vent-dwelling tube worms discovered near these chimneys turned out to be among the fastest-growing marine invertebrates ever documented, capable of reaching lengths of several feet within just a couple of years, an astonishing pace for an animal that has no mouth, no stomach, and no way to eat anything directly. Their entire survival depends completely on the bacteria living inside them, making each worm less like a single creature and more like a walking, growing container built specifically to host a colony of chemical-powered microbes. At the opposite end of the planet, in a place with almost no water flowing at all, something equally hidden sits buried beneath more than 2 miles of solid ice instead of ocean water. Antarctica holds 90% of Earth's ice and roughly 70% of its fresh water, locked into a frozen continent larger than the United States and Mexico combined. For most of human history, this ice seemed permanent, an unmoving white expanse at the bottom of the world. Satellites monitoring it closely over the last few decades have revealed something far less stable: massive chunks of ice breaking away from the continent's edges with increasing frequency, some pieces larger than entire small countries. In 2021, an iceberg researchers later identified by its own tracking code broke away off Antarctica's Ronna ice shelf, measuring roughly 1,000 square miles, briefly making it the largest iceberg on the planet, comparable in size to the entire island of Majorca. Researchers tracking Antarctica's ice shelves, the floating extensions of glaciers that help hold back the much larger ice sheet behind them, have documented an accelerating pattern of these massive calving events across multiple regions of the continent over the past 2 decades. Ice shelves matter far more than their size alone suggests. They act like a cork in a bottle, physically blocking the slow, grinding flow of glacial ice behind them from sliding directly into the ocean. When a major ice shelf collapses entirely, as happened dramatically with the Larsen B shelf in 2002, which disintegrated in just over a month after remaining stable for roughly 10,000 years, the glaciers it had been holding back can suddenly speed up, sometimes flowing into the ocean several times faster than before. Scientists tracking West Antarctica's Thwaites Glacier, nicknamed the Doomsday Glacier because of its potential to raise global sea levels by over 2 feet on its own if it fully collapsed, have found warm ocean water actively eating away at the glacier's underside from below, a process largely invisible from the surface and extremely difficult to measure directly. Researchers currently estimate this single glacier alone could become unstable within the coming decades, though significant uncertainty remains around the exact timeline. Researchers flying repeated radar surveys over Antarctica have also documented enormous cracks spreading silently across shelves that appeared stable for decades, sometimes stretching for miles beneath a snow-covered surface that looks completely undisturbed from above. The Brunt Ice Shelf, monitored closely by the British Antarctic Survey, developed a crack scientists nicknamed Halloween Crack after it suddenly extended for miles in a single day back in 2016, eventually contributing to a massive iceberg breaking free years later, exactly the kind of slow building, then sudden failure pattern researchers now watch for across the entire continent. None of this means Antarctica is collapsing overnight, and scientists studying ice shelf carving stress that some level of ice breaking away is a completely normal part of how glaciers have always behaved, even without any warming at all. What has changed is the frequency and scale of these events, along with clear evidence that warming ocean water is actively accelerating the process in specific vulnerable regions. Beneath all of this shifting, cracking ice sits something even stranger, an entire hidden world of liquid water that has never once seen daylight. Under more than 2 miles of solid Antarctic ice, at the very bottom of the frozen continent, sits a lake the size of Lake Ontario. It is called Lake Vostok, and it has remained completely sealed off from sunlight, from the atmosphere, and from any contact with the outside world for somewhere between 14 million and 25 million years, making it one of the most isolated environments anywhere on Earth's entire surface. Scientists first suspected Lake Vostok existed through radar surveys conducted from aircraft flying over Antarctica, detecting an unusually flat, smooth signal reflecting back from deep beneath the ice, exactly what liquid water would produce compared to the jagged, uneven signal returned by solid ice or rock. Since that discovery, researchers using increasingly precise satellite and radar mapping have identified over 400 similar subglacial lakes hidden beneath Antarctica's ice sheet, connected to each other through an extensive network of rivers and channels flowing silently in complete darkness. Kept liquid by heat rising from the rock below, combined with the immense pressure of miles of ice pressing down from above. The water in Lake Vostok stays liquid despite freezing surface temperatures because of this pressure and geothermal heat, similar to how pressure keeps water liquid deep inside a sealed container, even at temperatures that would freeze it anywhere else. Russian scientists finally drilled down and reached the lake's surface in 2012, after decades of careful, painstaking work designed specifically to avoid contaminating the ancient, untouched water with anything from the modern world above. What they found inside raised as many questions as it answered. Ice core samples taken from just above the lake's surface contained traces of unknown bacterial genetic material that did not closely match any previously catalogued species, sparking intense debate among microbiologists over whether the samples represented genuinely unique organisms adapted to this extreme isolated environment, or simply contamination introduced during the drilling process itself. Later, more carefully controlled sampling attempts have continued searching for definitive answers, though the extreme difficulty of studying a lake buried this deep keeps progress slow. Scientists have also detected liquid water moving beneath the ice sheet, covering Greenland, not in a single large lake like Vostok, but through an extensive network of smaller channels and reservoirs that shift with the seasons as surface meltwater drains downward through cracks called moulins. Researchers studying this hidden plumbing system believe it may actually help speed up how fast Greenland's ice slides toward the ocean, since a slick layer of water beneath the ice reduces friction, letting massive glaciers slide over bedrock faster than they would on dry, frozen ground alone. Scientists studying Lake Vostok see it as one of the closest analogues on Earth to the hidden subsurface oceans believed to exist beneath the icy crusts of Jupiter's moon Europa and Saturn's moon Enceladus, both considered leading candidates in the search for life beyond our own planet. If life has found a way to survive for millions of years, completely cut off from sunlight, in one of the most extreme environments Earth has to offer, it strengthens the case that similar hidden oceans on distant, icy moons might not be empty either. Far above this buried, ancient lake, something in the sky protecting the entire planet has been quietly behaving in ways that scientists cannot fully agree on either. In 1985, scientists confirmed a massive hole had opened in the ozone layer above Antarctica, a discovery that shocked the world and led to one of the most successful environmental treaties in human history, the Montreal Protocol, which banned the industrial chemicals responsible for destroying the ozone that shields Earth's surface from dangerous ultraviolet radiation. Decades later, that hole has been steadily shrinking, and the World Meteorological Organization's 2024 report confirmed the healing process continues roughly on schedule, with full recovery over Antarctica currently projected sometime around 2066. That is genuinely good news, and one of the clearest examples in modern history of humanity identifying an enormous environmental threat and successfully fixing it through coordinated global action. A separate discovery has complicated the celebration. In 2022, physicist Qingbin Liu at the University of Waterloo published research claiming to have identified an entirely different ozone hole, one sitting above the tropics rather than the poles, roughly 7 times larger in total area than the well-known Antarctic hole, and present year-round rather than appearing seasonally. According to this research, ozone levels in the lower stratosphere above the tropics, a region spanning 30 degrees north and south of the equator and home to roughly half the world's population, have been depleted by around 80% at their weakest point since sometime in the 1980s, entirely missed by the climate models scientists normally rely on to predict ozone behavior. This claim did not go unchallenged. Multiple atmospheric chemists quickly pushed back, arguing the methodology behind the tropical ozone hole study contained serious flaws, and that long-term ozone monitoring data from other well-established research programs shows no evidence supporting a hole of this scale or persistence. Some experts went as far as stating publicly that the described phenomenon simply does not match how ozone chemistry works, based on decades of prior research. The original 1985 discovery of the Antarctic hole came from an unusually persistent research team at the British Antarctic Survey, who kept measuring unexpectedly low ozone readings for years and, rather than assuming their instruments were broken, sent the data to be checked by NASA satellites orbiting overhead. Those satellites confirmed the same alarming pattern from space, and within just 2 years of that confirmation, representatives from dozens of countries had signed the Montreal Protocol, a speed of global political action that remains rare for any environmental problem before or since. This leaves an unusual situation for something as heavily studied as Earth's ozone layer, one confirmed hole steadily healing above the coldest place on the planet, thanks to decades of deliberate human effort, and one disputed, unconfirmed claim of a second, much larger hole above the warmest, most densely populated part of the planet, still being debated by experts who study the atmosphere for a living. Whichever side turns out correct, it is a reminder that even something as thoroughly researched as the layer of gas, protecting every living thing from the sun's radiation, still holds room for genuine scientific disagreement, the same kind of disagreement scientists face when trying to explain sounds coming from the sky itself, sounds nobody has ever been able to fully trace back to a source. Just before 9 in the morning on January 23, 1994, residents across a stretch of the northeastern United States and Canada reported a powerful boom loud enough to rattle windows, shake houses, and send some people running outside convinced a plane had crashed nearby or an earthquake had struck. No plane crash was ever found. No earthquake was ever recorded strong enough to explain it. This event, later nicknamed a skyquake, remains formally unexplained to this day, one entry in a long, strange list of mysterious booms recorded around the world for more than a century. Similar unexplained booms have been reported regularly along the coast near Wilmington, North Carolina, so consistently that locals gave them their own nickname, the Seneca Guns, after similar sounds reported near Seneca Lake in New York, going back over 200 years, long before airplanes, sonic booms, or modern military testing could possibly explain them. Coastal booms have also been documented for generations in Belgium, the Netherlands, and parts of Italy, often on calm, clear days, with no storms, no aircraft, and no recorded seismic activity anywhere nearby. Alongside the booms sits an equally strange, quieter mystery known simply as the hum, a persistent, low-frequency droning sound that only a small percentage of people in certain locations can actually hear, loud enough in some reported cases to disrupt sleep and daily life for years at a time. Documented cases include the Taos hum in New Mexico and the Bristol hum in England, both studied repeatedly by acousticians and government researchers without ever reaching a single, confirmed explanation that satisfied everyone involved. Scientists have proposed a range of possible explanations for these phenomena over the decades, including distant industrial machinery, unusual atmospheric pressure waves capable of traveling long distances, underwater seismic activity, too subtle for standard equipment to register clearly, and in some individual cases, a form of tinnitus specific to certain ranges of low-frequency hearing. None of these explanations have ever been definitively confirmed for the majority of reported cases, and some incidents remain entirely unresolved, filed away in scientific literature as simply unexplained. The United States Geological Survey investigated several of the loudest reported boom clusters directly, deploying seismic equipment specifically designed to catch events too subtle for ordinary earthquake sensors to register clearly. In some cases, investigators found faint evidence of small, shallow tremors coinciding with reported booms, suggesting at least a portion of these events may trace back to minor shifts along buried fault lines, never large enough to register on standard earthquake scales, though this explanation still fails to account for every documented case, particularly the ones felt far from any known fault at all. What makes these mysteries different from most others in this video is that they require no deep ocean submersible, no satellite in orbit, and no drill reaching miles underground to encounter. They can happen in an ordinary backyard, on an ordinary morning, heard or felt by ordinary people who have no way to explain what just happened around them. Every discovery covered so far, the reversing core, the wandering pole, the sinking cities, the ancient viruses waking up, the current that could freeze a continent, points toward the same underlying truth about the planet every single person alive is currently standing on. Every year, the moon moves about 1.5 inches farther away from Earth, roughly the same distance your fingernails grow annually. Astronauts left mirrors on the lunar surface during the Apollo missions, specifically so scientists on Earth could bounce laser beams off them and measure this drift with incredible precision, timing exactly how long the light takes to travel there and back. This slow retreat happens because of tides. As the moon's gravity pulls on Earth's oceans, it creates a slight bulge of water that drags very slightly ahead of the moon's position. Due to Earth's own rotation, that bulge tugs the moon forward in its orbit, giving it a tiny boost of energy that pushes it into a slightly wider orbit each year, while Earth loses a matching amount of rotational energy in return, which is part of why our days have been slowly getting longer over deep geological time, even as short-term wobbles occasionally speed things up. 3 billion years ago, the moon sat far closer to Earth than it does now, and calculations based on that closer distance suggest a full Earth day back then lasted somewhere close to 19 hours rather than 24. Tides driven by a much closer moon would have been dramatically more powerful too, potentially towering many times higher than anything oceans experience today, constantly reshaping coastlines on a planet that barely resembled the one we know now. Run the clock forward instead of backward, and the moon's slow retreat leads somewhere genuinely strange. Roughly 600 million years from now, astronomers calculate the moon will have drifted far enough away that it will appear noticeably smaller in Earth's sky, no longer large enough to fully cover the sun's disk during an eclipse. Total solar eclipses, the kind where day briefly turns to night and the sun's outer atmosphere becomes visible, will stop happening entirely, replaced permanently by weaker annular eclipses, sometimes called ring of fire eclipses, where a bright ring of sunlight always remains visible around the moon's edge. This same tidal relationship helped scientists reconstruct just how different Earth once looked using an unlikely source: fossilized coral. Ancient coral grows a visible daily ring, much like a tree grows yearly rings. And by counting how many rings formed within a single fossilized year, researchers determined that a year 400 million years ago contained around 420 days, rather than the current 365. Direct physical proof, preserved in stone, that days back then were noticeably shorter than the ones we experience now. Humanity happens to exist during an extraordinarily specific window in Earth's multi-billion-year history. The roughly narrow stretch of time where the moon's exact size and distance allow it to align perfectly with the sun, as seen from our particular planet, an astronomical coincidence that will not last forever. Every total eclipse witnessed by every human throughout history, going back to the earliest ancient civilizations, has happened inside a cosmic window that is slowly, permanently closing 1.5 inches at a time, while a very different kind of disappearance has been unfolding much closer to home, in landscapes that were fertile just a single human lifetime ago. The Aral Sea, once the 4th largest lake on Earth, straddling the border between modern-day Kazakhstan and Uzbekistan, has lost over 90% of its total volume since the 1960s, when Soviet engineers diverted the rivers, feeding it to irrigate massive cotton farms across Central Asia. Fishing boats that once sailed across open water now sit rusting on cracked, salt-covered desert, sometimes miles from any remaining shoreline, monuments to a body of water that vanished within a single human lifetime. Deserts across the planet are expanding at a similarly alarming pace that has alarmed researchers for decades, a process called desertification, where fertile land gradually loses its ability to support plants and crops, usually driven by a combination of drought, overgrazing, deforestation, and unsustainable farming practices. China's Gobi Desert has expanded so aggressively that authorities have planted an enormous barrier of trees, sometimes called the Great Green Wall, stretching thousands of miles, specifically to slow sand from swallowing farmland and reaching all the way to the outskirts of Beijing during major dust storms. The United Nations estimates that roughly 40% of Earth's land surface is already classified as some form of dryland, and a significant portion of that land faces ongoing degradation risk, threatening the food and water security of billions of people who depend directly on that land for farming and grazing livestock. Sub-Saharan Africa's Sahel region, a narrow band sitting just south of the Sahara Desert, has experienced such severe repeated droughts that entire farming communities have been forced to permanently relocate, some crossing international borders in search of land that can still support crops. Unlike some of the deep, slow processes covered earlier in this video, desertification is one of the few forces reshaping Earth's surface that happens almost entirely because of choices made by humans through farming practices, water diversion, and land management decisions, rather than forces buried miles underground or locked into ancient orbital cycles. That also makes it one of the few forces on this entire list that could, at least in some regions, be slowed or partly reversed through different choices, something scientists studying successful reforestation projects in parts of Africa's Sahel have already demonstrated is genuinely possible on a local scale. China's approach to fighting its own expanding desert has become one of the largest tree planting efforts ever attempted by any government, with workers having planted tens of billions of trees since the project began, aiming eventually to plant a green belt roughly the length of the distance from New York to Los Angeles and back again. Early results have been mixed, since some fast-growing species chosen for the project struggled to survive the very dry conditions they were meant to fight, teaching researchers that stopping a desert's advance takes more than simply planting as many trees as possible. The ocean tells a strikingly similar story to the vanishing Aral Sea, except instead of water disappearing entirely, what has been dying is something living inside it, in colors so vivid they used to be visible from space. The Great Barrier Reef, stretching across roughly 1,400 miles off the coast of Australia, is the largest living structure on Earth, so massive it can be seen clearly from orbit. It is built entirely by tiny animals called coral polyps, each barely larger than a grain of rice, working together across countless generations to construct elaborate calcium skeletons that eventually form entire underwater cities, home to a quarter of all known marine species, despite covering less than 1% of the ocean floor. Coral gets its vivid color from microscopic algae living inside its tissue in a close partnership where the algae provide food through photosynthesis in exchange for a safe, sunlit home. When ocean water gets too warm, even by just a degree or two above normal, for a sustained period, coral becomes stressed and expels these colorful algae, leaving behind a stark white skeleton in a process scientists call bleaching. Bleached coral is not automatically dead, and reefs can recover if temperatures drop back to normal quickly enough. But repeated or prolonged bleaching events leave corals starving, more vulnerable to disease, and eventually likely to die entirely if conditions do not improve. The Great Barrier Reef has now experienced multiple mass bleaching events within a single decade, a pace scientists studying coral reefs describe as unprecedented compared to historical patterns, where reefs previously had roughly 10 to 15 years between major bleaching events, enough time for meaningful recovery in between. Researchers surveying the reef after the most severe bleaching years found some sections had lost the majority of their shallow water coral entirely, transforming vibrant, densely populated reef systems into pale, broken skeletons within just a few months. Coral reefs across the Caribbean, Southeast Asia, and the Indian Ocean have reported the same pattern in recent years, driven by marine heat waves that scientists link directly to rising global ocean temperatures. Some particularly severe heat wave events have pushed ocean temperatures in localized regions several degrees above any level ever recorded there before. Conditions, coral reefs, which took thousands of years to build themselves through slow, patient growth, have never had to survive before in their evolutionary history. Some coral species have shown a surprising ability to adapt faster than scientists initially expected. Researchers studying reefs in the Persian Gulf, where water temperatures already regularly exceed anything seen on the Great Barrier Reef, found coral there surviving heat levels that would completely bleach and kill reefs almost anywhere else on the planet. Marine biologists have begun collecting samples from these unusually tough Gulf corals, specifically to study what makes them different, hoping their natural heat tolerance might eventually help restore damaged reefs elsewhere through careful, selective breeding programs. Scientists studying reef resilience have found some hope in coral populations that appear naturally more heat tolerant, along with active restoration projects growing new coral in nurseries before transplanting it onto damaged reefs. Whether these efforts can keep pace with how quickly ocean temperatures are rising remains an open, urgent question, one connected to an entirely different kind of collapse happening much higher up in the cold, fast-moving currents of air that control winter weather across entire continents. In February 2021, an extreme winter storm plunged Texas into days of brutal, record-breaking cold, knocking out power for millions of people across a state that almost never sees temperatures this severe, resulting in hundreds of deaths and billions of dollars in damage. The cause traced back not to anything happening in Texas itself, but to a sudden, dramatic event occurring roughly 19 miles above the North Pole, in a layer of atmosphere most people never think about at all. High above the Arctic, a fast-moving ring of freezing air called the polar vortex normally spins in a tight, stable pattern throughout winter, effectively trapping the coldest air close to the pole and keeping it away from the rest of the world. Occasionally, this stable pattern breaks down suddenly in an event scientists call sudden stratospheric warming, where temperatures in the upper atmosphere can spike dramatically within just a few days, sometimes rising more than 100 degrees Fahrenheit in that short window, disrupting the vortex enough to cause it to stretch, wobble, or even split apart entirely into smaller pieces. When the polar vortex splits or stretches like this, it does not simply disappear. Fragments of that intensely cold Arctic air can slide directly southward, sometimes reaching as far as Texas, northern Mexico, or southern Europe, bringing genuine Arctic conditions to regions with infrastructure never designed to handle that kind of cold. This is part of why extreme winter cold snaps can still occur even as the planet's overall average temperature continues rising, an apparent contradiction that has fueled public confusion for years. Since a single freezing week gets mistaken by some as evidence against a warming planet, when it actually represents a disrupted, destabilized version of a system that global warming appears to be affecting. Some climate researchers have proposed a direct connection between Arctic warming and these disruptive vortex events, arguing that rapid warming of the Arctic, which has been heating roughly 4 times faster than the global average in recent decades, weakens the temperature difference that normally keeps the polar vortex spinning in its stable, contained pattern. Other atmospheric scientists remain more cautious about this specific link, noting that sudden stratospheric warming events have been documented and studied since long before recent rapid Arctic warming began, making a definitive cause and effect relationship genuinely difficult to prove with current data. the February 2021 Texas freeze that followed one of these vortex-splitting events left more than 4.5 million homes and businesses without power at the coldest point of the crisis. Since the state's electrical grid, built almost entirely for extreme summer heat, had few of its power plants properly insulated against extreme cold. Investigators later found that natural gas wellheads froze solid across the state, cutting fuel supply to power plants at the exact moment demand for heating spiked hardest, turning an atmospheric event happening miles above the Arctic into a deadly, entirely earthbound infrastructure failure. What researchers agree on more broadly is that winter weather patterns across North America, Europe, and Asia have become measurably more volatile and harder to predict over the past 2 decades, swinging between unusually mild stretches and sudden extreme cold snaps within the same season. High above the frozen surface, this invisible battle in the stratosphere plays out completely unseen by anyone standing below it, much like an entirely separate form of life that scientists have only recently confirmed exists, buried miles beneath solid rock where no vortex, no sunlight, and no weather of any kind has ever reached. Miles beneath the surface, inside solid rock so dense it would crush almost anything. Scientists have confirmed the existence of an entire hidden biosphere, one that may contain more living organisms by total mass than every animal living on Earth's surface combined. Researchers call it the deep biosphere, and it exists in complete darkness, under crushing pressure, at temperatures that would be lethal to almost any surface-dwelling creature, in rock that was assumed for most of scientific history to be completely sterile. Discovery of this hidden world came gradually, through mining operations, deep drilling projects, and specialized scientific expeditions specifically designed to search for life in rock samples pulled from staggering depths, in some cases more than 2.5 miles below the surface. Microbes found living at these depths survive on almost nothing by ordinary standards. Some feeding on hydrogen produced when groundwater reacts slowly with certain types of rock, others surviving on radiation released naturally by trace radioactive elements scattered through the surrounding stone, essentially eating the planet's own background radioactivity as their sole source of energy. What makes this discovery genuinely remarkable is where these organisms live, and just as much, how slowly they seem to live. Some deep rock microbes appear to reproduce only once every few thousand years, an almost unimaginably slow pace of life compared to surface bacteria that can reproduce multiple times within a single hour. Researchers studying these organisms describe their existence less like a fast-paced ecosystem and more like a form of biological suspended animation, barely alive by ordinary standards, yet clearly, measurably alive, and clearly capable of surviving conditions that would instantly kill nearly everything living on the surface above them. The total scale of this hidden world staggers most people who first hear about it. A major international research project, spanning over a decade, involving more than 1,000 scientists across dozens of countries, estimated that the deep biosphere could contain somewhere between 15 and 23 billion tons of carbon locked inside living organisms, an amount roughly hundreds of times greater than the combined weight of every single human being currently alive on Earth's surface. Some of the deepest confirmed life on record was found in a South African gold mine, where researchers drilling nearly 2 miles underground discovered a single species of bacteria living completely alone, with no other organism sharing its environment at all, surviving entirely on hydrogen produced by radioactive decay in the surrounding rock. Scientists studying this isolated microbe estimate it may represent one of the simplest complete ecosystems ever found on Earth, a single species surviving indefinitely, without needing any other form of life around it whatsoever. This discovery has reshaped how scientists think about the basic requirements for life itself, both on Earth and elsewhere. If life can survive for potentially billions of years, isolated completely from sunlight, from the surface, and from anything resembling a normal ecosystem, buried in solid rock miles underground, it dramatically expands where astrobiologists now consider it realistic to search for life on other worlds, including deep inside the crust of Mars, a planet where similarly ancient, isolated rock has remained largely undisturbed for billions of years. Sea level does not sit at the same height everywhere on Earth, even after accounting for tides, currents, and waves. If you could magically drain every ocean down to a perfectly still, motionless surface shaped only by gravity, that surface would not form a smooth, even sphere at all. It would bulge and dip unevenly across the planet, and one of the most dramatic dips on the entire globe sits in the middle of the Indian Ocean, an area scientists call the Indian Ocean Geoid Low. At its deepest point, roughly the middle of the sea between India and Madagascar, sea level actually sits about 6 feet lower than the global average would predict, purely because gravity itself is measurably weaker in that specific location, pulling ocean water away from that spot and toward areas with slightly stronger gravitational pull elsewhere on the planet. The cause sits far below the surface entirely, in differences of density hundreds of miles beneath the seafloor, in the mantle rock churning far below. For decades, the leading explanation involved cold, dense material sinking downward in that specific region, material left over from ancient tectonic plates that had long since been swallowed into the mantle through subduction, the same process that recycles ocean floor back into the depths of the Earth over millions of years. A team of researchers using advanced computer modeling in 2023 proposed a different, more dramatic explanation that the geoid low might actually be caused by plumes of unusually hot, low-density magma rising upward from deep within the mantle, remnants connected to an ancient ocean that existed long before India collided with Asia, roughly 50 million years ago. Scientists remain genuinely divided over which explanation better fits the evidence, and resolving the debate requires extremely detailed seismic imaging of mantle structure that researchers are still actively refining. What both competing explanations agree on is the underlying reality that gravity itself, something most people assume is perfectly uniform everywhere on Earth, actually varies measurably from place to place, shaped by hidden currents of rock churning hundreds of miles beneath the waves, currents connected to the exact same deep mantle system responsible for the giant blobs beneath Africa and the Pacific covered earlier in this video. Similar gravity dips and bulges exist scattered across the rest of the planet too, though none nearly as dramatic as the one over the Indian Ocean. Scientists use a network of specialized satellites, specifically designed to map these subtle variations with extreme precision, producing a lumpy, uneven model of Earth's true shape that geophysicists call the geoid, a shape far closer to a slightly dented potato than the smooth, perfectly round sphere most people picture when they imagine planet Earth from space. While gravity quietly reshapes the ocean surface from hundreds of miles below, a much smaller, much more fragile form of life closer to the surface has been vanishing at a pace that threatens the food supply of nearly every land animal on the planet, including humans. Roughly 1 out of every 3 bites of food eaten by humans depends, at some point, on pollination carried out by insects, primarily bees, along with butterflies, moths, and countless other lesser-known species working quietly across farms and wild landscapes worldwide. Over the past few decades, scientists tracking insect populations across multiple continents have documented sharp, widespread declines severe enough that some researchers have started calling it an unfolding insect apocalypse. A major long-term study conducted across protected nature reserves in Germany, published in 2017, found that the total mass of flying insects captured in standardized traps had dropped by more than 75% over just 27 years, a decline so severe that researchers initially assumed some kind of measurement error until repeated testing across multiple additional sites confirmed the same dramatic pattern. Similar declines, though varying in severity, have since been documented in Puerto Rico's rainforests, in agricultural regions across the United States, and among specific well-studied groups like monarch butterflies, whose population along one major migration route has fallen by well over 80% since the 1990s. Scientists studying this decline point to several overlapping causes rather than a single simple explanation, including widespread pesticide use, particularly a class of chemicals called neonicotinoids that affect insect nervous systems even at extremely low concentrations, along with habitat loss as wild grasslands and meadows get converted into farmland or developed land, and rising temperatures disrupting the delicate seasonal timing many insects depend on to synchronize with flowering plants. Honeybees specifically have faced an additional, still partially mysterious threat called colony collapse disorder, first documented widely around 2006, where entire hives of worker bees abandon their queen and vanish suddenly, leaving behind a fully stocked, healthy-looking hive with no adult bees left to run it. Researchers have identified several likely contributing factors, including a parasitic mite called Varroa destructor, viral infections, the mites help spread, and pesticide exposure, though scientists studying the disorder note that isolating one single definitive cause has proven difficult, given how many stresses affect bee colonies simultaneously. Some regions have already tested what happens when this decline goes largely unmanaged. Parts of China's Sichuan province lost so many wild pollinators decades ago, largely from heavy pesticide use, that farmers there have resorted to hand-pollinating entire pear orchards using brushes, climbing tree to painstakingly transfer pollen by hand, a slow, expensive process that insects had performed automatically and for free across the same orchards for as long as anyone could remember before the bees mostly disappeared. Insects sit at a foundational position in nearly every land-based food web on the planet, pollinating crops, breaking down dead plant and animal material, and serving as a primary food source for birds, fish, and countless other animals. A collapse significant enough to disrupt that foundation would ripple outward through ecosystems far beyond anything limited to farms alone, a warning scientists take seriously, even as debate continues over exactly how severe and how widespread the overall decline truly is. On a peninsula in the North Atlantic, a very different kind of dormant force has recently reawakened after staying almost completely silent for longer than recorded human history in the region. For nearly 800 years, the volcanic systems running through Iceland's Reykjanes Peninsula sat completely dormant, quiet long enough that generations of Icelanders lived their entire lives assuming this particular stretch of land, home to the country's main international airport and the popular Blue Lagoon geothermal spa, was simply not volcanically active at all. In March 2021, that assumption ended abruptly when a fissure eruption opened up, sending glowing rivers of lava spilling across the landscape for the first time in centuries. That eruption turned out to be only the beginning. Since 2021, the Reykjanes Peninsula has experienced repeated volcanic eruptions, with magma repeatedly forcing its way toward the surface through a network of underground channels that geologists are still working to fully map. In late 2023 and through 2024, eruptions grew close enough to the town of Grindavik that authorities evacuated the entire population, while lava flows damaged roads, cracked open the ground beneath homes, and at one point came dangerously close to the critical geothermal power plant that supplies electricity and hot water to a significant portion of the surrounding region. Scientists monitoring the peninsula using satellite positioning stations and satellite radar have tracked magma repeatedly, accumulating in an underground chamber roughly 2.5 miles beneath the surface, inflating the ground measurably before each new eruption, similar in principle to the breathing pattern observed at Yellowstone, except here the pressure has been building toward actual eruptions rather than simply rising and settling back down again. Researchers studying the historical pattern of this specific volcanic system found evidence that Reykjanes tends to move through extended cycles, staying completely dormant for roughly 800 to 1,000 years, followed by an active period lasting several centuries, marked by repeated eruptions similar to what has now begun. If that historical pattern holds true, Iceland may be entering a volcanically active era on the Reykjanes Peninsula that could continue producing eruptions for generations, reshaping the local landscape gradually, the same way earlier active periods, visible in the layered lava fields covering much of the peninsula today, did centuries ago. Geologists studying Iceland stress this activity, while genuinely dangerous to nearby towns and infrastructure, remains a well-understood, closely monitored type of volcanic behavior, distinct from the far rarer, far more catastrophic supervolcano eruptions discussed earlier at Yellowstone. Icelandic authorities have leaned heavily on their extensive network of underground sensors and satellite monitoring to issue warnings well before lava actually breaches the surface. A system credited with preventing any confirmed deaths despite repeated eruptions occurring dangerously close to a populated town. Engineers have gone as far as building earthen defensive walls around the critical geothermal plant near Grindavik, specifically designed to redirect oncoming lava flows away from the buildings, a modern defense against a force of nature that has been reshaping this exact stretch of coastline for thousands of years. Beneath a much colder stretch of water not far from Iceland, fishing trawlers have spent decades hauling up evidence of an entirely different landscape, one that used to support human life before the ocean itself quietly swallowed it whole. Fishing trawlers, working the shallow waters of the North Sea, between modern-day Britain and continental Europe, have spent decades occasionally pulling up something startling in their nets. Alongside fish, ancient bones belonging to woolly mammoths, lions, and other Ice Age animals, sometimes accompanied by primitive stone tools clearly shaped by human hands. These objects come from a landscape that no longer exists on any map, a vanished region archaeologists call Doggerland. Roughly 12,000 years ago, at the end of the last Ice Age, so much of the planet's water remained locked into massive ice sheets that global sea levels sat considerably lower than they do today, exposing an enormous stretch of dry land connecting what is now Britain directly to mainland Europe. Doggerland covered an area larger than many modern countries, filled with rivers, lakes, forests, and rolling hills, and archaeological evidence confirms thousands of Stone Age hunter-gatherers lived there for generations, hunting, fishing, and building their lives across a landscape now sitting more than 100 feet underwater. As Ice Age glaciers melted and global sea levels rose steadily over thousands of years, Doggerland did not vanish overnight through one dramatic catastrophe. It disappeared gradually, decade after decade, as rising water slowly swallowed low-lying areas first, pushing communities to retreat toward higher ground that itself would eventually flood too, generation after generation losing more usable land until almost nothing remained above the surface. Researchers studying sediment cores from the seafloor have also found evidence suggesting one final, sudden event may have accelerated the process near the very end. A massive underwater landslide off the coast of Norway that likely triggered a significant tsunami, capable of overwhelming whatever remaining coastal areas of Doggerland still existed at that point. Marine archaeologists have spent recent years mapping the submerged landscape in remarkable detail, using sonar technology originally developed for oil and gas exploration to trace ancient riverbeds, hills, and coastlines now buried under sediment on the sea floor. Some researchers have even proposed testing seafloor sediment for traces of ancient genetic material, hoping to identify exactly which plants and animals once lived across this lost landscape before it disappeared beneath the waves entirely. A well-preserved skull belonging to a Neanderthal, along with the remains of woolly rhinoceroses and other Ice Age megafauna, has been dredged from the seafloor by fishing crews working the same waters where Doggerland once stood, offering rare physical evidence that predates even the Stone Age. Hunter-gatherer communities archaeologists have studied most closely there. Researchers now argue that the entire southern North Sea should be treated as a genuine archaeological site in its own right, one that happens to be submerged, rather than simply an empty stretch of fishing water. Doggerland stands as a powerful, tangible reminder that the coastlines humans currently treat as permanent and fixed have shifted dramatically before, well within a time frame that human communities directly experienced and adapted to themselves. An entire inhabited landscape, once home to real families building real lives, now sits silently beneath the waves, discovered one fragment at a time, dragged up in fishing nets by people who have no idea what they just found. Scientists studying the fossil record have identified 5 previous mass extinction events throughout Earth's deep history, each one wiping out a staggering percentage of all species alive on the planet at that time, including the event that ended the age of dinosaurs roughly 66 million years ago, when a massive asteroid impact triggered catastrophic climate disruption across the entire globe within a matter of years. A growing number of researchers now argue Earth has entered a 6th such event, driven this time not by an asteroid or a volcanic catastrophe, but by the activity of a single species currently reading these very words. Current species extinction rates, based on careful analysis published by researchers studying vertebrate populations worldwide, run somewhere between 100 and 1,000 times faster than what scientists calculate as the natural background rate, the steady, slow pace at which species would normally disappear without any unusual outside pressure. A widely cited 2019 United Nations report, compiled by hundreds of scientists across dozens of countries, estimated that roughly 1 million plant and animal species currently face extinction risk within decades, many potentially disappearing within the lifetime of children being born today. Unlike the asteroid impact that ended the age of dinosaurs, this current wave of extinction traces back to a combination of overlapping pressures, habitat destruction as forests and wetlands get cleared for farming and development, overhunting and overfishing, beyond what populations can naturally replace, the introduction of invasive species into ecosystems that never evolved defenses against them, pollution, and a rapidly warming climate shifting habitats faster than many species can adapt or relocate. Some scientists studying this pattern push back against the framing of a 6th mass extinction, arguing that comparing current losses directly to the 5 previous catastrophic events, several of which wiped out the vast majority of all species on Earth within a geologically short window, may overstate how far along the current crisis actually is. What almost every researcher studying biodiversity agrees on, regardless of how the current moment gets labeled, is the underlying direction and pace, species disappearing measurably faster than at almost any other point across recorded scientific observation, driven overwhelmingly by the choices and activity of one single species. Some of the clearest evidence for the current extinction wave comes from amphibians, specifically a group of animals particularly sensitive to environmental change because they breathe partly through their skin and need both clean water and healthy land habitat to survive. Nearly 40% of all known amphibian species are currently classified as threatened with extinction, a proportion far higher than for mammals, birds, or reptiles, making frogs and salamanders an early, sensitive warning system for environmental stress that researchers watch closely across every continent where they still survive. This raises a question serious enough that geologists themselves have spent years formally debating it in scientific committees, whether human activity has become powerful enough to leave its own permanent, unmistakable signature directly inside the rock layers of the planet itself. The same way ancient asteroid impacts and mass extinctions left their own signatures preserved in stone for scientists to discover millions of years later. Geologists divide Earth's 4.5 billion year history into a strict, formal timeline made up of eons, eras, periods, and epochs, each boundary marked by a permanent, physical signature preserved directly in layers of rock, ice, or sediment, evidence clear enough that scientists studying that rock millions of years in the future could identify exactly when one chapter of Earth's history ended and another began. For years, an international committee of geologists seriously debated whether human activity has become powerful enough to mark the start of an entirely new chapter. One they proposed calling the Anthropocene, literally meaning the age of humans. The case for this new epoch rests on genuinely striking physical evidence. Nuclear weapons testing, beginning in the 1940s, scattered a distinct layer of radioactive particles across the entire planet, embedded permanently into ice cores, tree rings, and sediment everywhere on Earth, detectable by scientists as a clear, sharp marker point in time. Plastic pollution has become so widespread that geologists have identified plastic fragments becoming a permanent, measurable component of sediment layers forming right now on ocean floors and riverbeds worldwide. Even domestic chicken bones, discarded by the tens of billions annually through modern industrial farming, have become so abundant and so anatomically distinct from wild birds that some researchers argue they could serve as a genuine marker fossil for this proposed new epoch, easily recognizable by geologists studying these layers millions of years from now. An international scientific committee spent over a decade formally evaluating whether to officially declare the Anthropocene a true geological epoch, eventually selecting a specific lake in Canada, Crawford Lake, as the leading candidate site to mark its formal starting point, based on annual sediment layers there that clearly recorded the exact signature of nuclear fallout beginning in the mid-20th century. In a decision that surprised many scientists who had worked on the proposal for years, the broader geological governing body ultimately voted against formally adopting the Anthropocene as an official epoch in 2024, with some geologists arguing that human impact, while undeniably real and severe, does not yet meet the strict, narrow technical definition required for a formal epoch boundary within their existing classification system. Crawford Lake, the small Canadian lake chosen as the leading candidate site for marking this proposed new epoch, was picked specifically because its unusually still, oxygen-poor bottom waters allow sediment to settle in distinct, undisturbed annual layers, almost like the pages of a book, each one recording a near-perfect snapshot of exactly what fell into the lake that particular year. Scientists studying its layered mud found a clear, sharp spike in radioactive particles beginning in 1950, a boundary so precise that researchers could point to the exact layer and say, with real confidence, that this is where one version of Earth's story ended and another one began. That formal rejection has not ended the broader conversation. Many scientists across multiple fields continue using the term Anthropocene informally and extensively in published research, arguing the underlying evidence for a fundamental, human-driven shift in how the entire planet functions remains undeniable, regardless of what any official committee ultimately decides to call it. Whatever label future generations eventually settle on, every single discovery covered throughout this entire video, the reversing core, the sprinting magnetic pole, the sinking cities, the vanishing lakes, the reawakening volcano, the hidden continent, the ancient viruses stirring back to life, now sits alongside a permanent, undeniable layer of evidence showing that humans themselves have become one of the active forces reshaping this planet, right alongside its molten core, its shifting mantle, and its wandering, restless magnetic field. Every discovery covered across this entire video shares one quiet truth underneath it. Earth has never once been the fixed, unchanging backdrop it appears to be from the surface of any single day. Its magnetic poles wander, its inner core drifts backward and forward across a cycle lasting decades. Its oceans carry heat around the globe on a conveyor belt, now showing genuine signs of strain. Its deserts turn green and then dry out again, following a rhythm set by nothing more than a slow tilt in its orbit around the sun. Scientists studying every single mystery in this video, from the reversing core to the wandering magnetic pole, to the still unexplained booms echoing across coastlines for centuries, keep arriving at the exact same humbling conclusion. The tools available today, satellites capable of detecting groundwater from orbit, seismic networks capable of mapping structures thousands of miles underground, drilling technology capable of reaching lakes buried under 2 miles of solid ice, have only existed for a small fraction of scientific history. Each new tool built keeps revealing forces that had been operating in complete silence for the entire span of human civilization, utterly invisible until precisely the right instrument finally arrived to detect them. This is a story about scale, about timescales far longer than any single human lifetime, sometimes far longer than the entire existence of human civilization itself, about a planet complex enough that entire scientific careers get built around studying one single, narrow piece of it, a wandering magnetic pole, a shrinking glacier, a single lost continent, hiding in plain sight beneath the waves for millions of years before anyone thought to look properly. Somewhere, right now, an atomic clock in a quiet laboratory is measuring today's exact length down to the millisecond. A satellite is passing silently overhead, tracking gravity itself as it shifts in response to water no one can see. A seismograph is recording faint vibrations rippling up from an earthquake that struck an ocean away, vibrations that will spend the next several minutes traveling straight through a hidden metal sphere buried nearly 2,000 miles beneath your feet, still turning at its own quiet, mysterious pace, exactly as it has for longer than humans have existed to wonder about it at all. None of this required a telescope pointed outward at some distant alien world. Every single mystery in this video was found by pointing instruments straight down into rock, ice, and water that has been sitting beneath human feet the entire time civilization existed. A hidden continent waited under 3 hours of ordinary ferry water for over 200 years of European exploration before anyone thought to check what lay beneath the waves properly. A reversing metal heart the size of the moon has been turning under every single person who has ever lived, felt by no one, measured by almost no one, until the right combination of earthquakes and patient scientists finally arrived to listen closely enough. The ground beneath your feet was never actually still. It only ever looked that way.